But then in 1992, a new administration came into power at NASA, and Zubrin saw a second chance.
I was invited to brief Mike Griffin, who was the Associate Administrator for Space Exploration in charge of the whole Space Exploration Initiative. He immediately became a very strong supporter of Mars Direct.
But before the engineers at NASA would take another look at Mars Direct, they wanted Zubrin to prove that producing rocket fuel on Mars could work. Zubrin and his team built a machine called the in-situ propellant plant. It could take carbon dioxide, the dominant gas in the Martian atmosphere, combine it with a little hydrogen, and produce a methane-oxygen fuel.
We did it in 3 months with a very small team. We built a plant that was 94% efficient, and no one who actually participated in that effort was actually a real chemical engineer. They were all aerospace engineers, like me, who were simply dabbling in chemistry in order to prove to NASA that 19th century chemical engineering really worked.
With the experiment a success, the administration had Zubrin give detailed briefings of the mission plan to the engineers at the Johnson Space Center. They liked it, but had some problems. Dave Weaver was the lead mission architect.
There were a number of things that we were concerned about with Bob Zubrin's mission. First of all, we thought his estimates of mass were probably too optimistic. Didn't have sufficient margins for a variety of things, not the least of which would be things like provisions for the crew, the amount of water that would be required. We thought his ascent vehicle was very large, which meant his power requirements, his propellant requirements were much larger than needed to be. His trip times out were too long, and that for very little effort you could get them shorter. The other problem was the size of his crew. He had a 4-person crew. I think virtually every study that's been done says that a 4-person crew for a 3-year type of mission is probably not realistic.
Weaver took Zubrin into his office, and the two men worked out compromise mission architecture. First, Weaver wanted 3 launches for every mission instead of 2. The first year, 3 ships would launch: a MAV, Mars Ascent Vehicle, an unoccupied HAB, and an ERV, Earth Return Vehicle. The HAB and MAV would land on the surface and begin producing fuel for the return flight and air for the crew. These craft would spend 2 solitary years on Mars, allowing NASA to test all of the systems before sending a human crew.